Hello, how are you guys doing today? We're gonna play around with, or no, not play around. Excuse me. We're gonna do an overview of your module 2, chapter 2. Kind of the theoretical knowledge behind the scenes of the point, click, and forget that it kind of described to you when you're working with access or the database concepts. The big idea is to get from this particular chapter. So let's begin. We're gonna look at what a field is. Talk a little bit about tables and how tables are put together and how they relate. And talk about, we may even get into access a little bit and talk about relationships and making relationships. You have quite a bit of information on relationship making from your book, but we might actually make an attempt at creating a relationship from some of your example. We'll just make some stuff up. That's fine, and do a relationship. So that'll be something that we do towards the end of our talk. Let's start with guidelines for designing a database. And so the purpose of a database obviously is to hold data, but what are some of the far-reaching fundamentals of a proper database? And one of those, and the primary part, that the parts of the data that is the most important, is anything that has to do with losing data or mislabeling data. Those are the big no-nos, and they're the reason why we have databases in this technology to structure these rules for us and make sure that we don't have a data issue. And what's one of the main things that a hacker would love to do is grab a hold of a hospital and its database and hold it hostage by encrypting it. Because essentially the hospital can't function. They can't function without computers and their data. It's all built in their policies and procedures so that they can provide a good service, obviously, and then also not screw up. That's also another thing to think about with data, is it's also a safety thing. And that goes right back to the hospitals. If some data of a certain medication got lost and a patient was assigned a medication that would potentially cause a lot of problems with medication interaction, all that is kind of part of it. So anything that you can imagine about computers, the most important part of a computer and its ability to compute is what it computes on. What is the data that it uses? That's the whole reason for a computer to exist, is for that data and that information. And so having a standard accepted way of holding information and allowing access to it is why we use databases. And so the standard part of it is, of course, having unique data that uses the smallest. When we say unique data, we don't want data that's frivolous. We want the most useful data. And then we want to relate that data. And of course, with related data, we can find how data relates to other data, how it does not relate to other data, and then of course, whatever you need the data for. So we talk about the data in access, and I'm saying, there's a lot of different words for referring to the data: a field, a record, a column, a row. It's the thing that's in the box. So the data is actually very, very simple. And this is one thing that I want to get across with this idea of, well, what kind of data are we storing? Well, we've got all kinds of different kinds of data, but the thing is all the data is the same. It's all numbers. Every single thing that you find, a field type, even if it gets complicated and you're like, I don't know what this particular field is. What kind of data is a calendar? What kind of data is this or that? It all comes down to a number, no matter what. It doesn't matter. So let's talk about the different kinds of numbers, though. That's where we are kind of at. And some of the main different kinds of numbers, there's two main low-level kinds of numbers, and that is, the integers, like the 1, a 2, not a 2.5. That's not what I'm talking about, because that we refer to as a floating point number. And we have different ways of working with this. This is also a currency. And Access has different ways of different data types that represents this, like the currency data type, or a floating point number that's not tied to currency. It could be some kind of other number. But here's the other type of number. It's just a number that is whole. And those we call integers, or whole numbers. And those are the most basic type of numbers that are being used in anything on a computer. Now let's really take this a little bit even further. Let me screenshot this. Oh, looks like it does not like me doing a screenshot. Okay, so let's just screenshot that. And let me see if I can't open that up in Paint. Oh, it usually pops up. Nah, that's whatever. Paint.net. Let's look up Paint.net. Because, when you're looking at this screen right here, and you're seeing all these windows, all this whiz bang this, whiz bang that, all of it's a number. So even just regular drawings, images, everything that is being rendered on the screen is a number, and it's very simple. It's a pixel. It's a pixel that has a specific location on your screen or within the window. And it's a pixel that is represented by that location using numbers. It's a pixel that is also represented with a color, and look at this, using numbers again. So look, these are all the numbers that describe the color of that pixel. So everything, it's a number. Now, there's a little nagging voice that might say, well, Mr. B, what about, you're missing one glaring, obvious data type that you haven't talked about. And what about, let's see, what about letter A? What about letter B, C? Or how about a sequence of letters, A, B, C, D? Well, we call that a string, or we call it a string. And every character in the string is, you guessed it, assigned a number. So if we look at what's called the ASCII code, the ASCII code declares what numerical values are assigned to your keyboard entries. And every key press is assigned a specific value, numerical value, that it corresponds with. So when you push the enter key, this is my favorite one. I like this one right here. Oh, come on, don't do that to me. There we go. So the enter key, that's the return. So that's in here. The lowercase a is 97. The uppercase A is 65. These are just different numbers, but the same number in different formats. So hexadecimal, and then the HTML reference code to that particular character set. And even the space is is put at 32. Now, interesting enough, if you've ever done any name sorting and somebody has a name that starts out with 0, 1, 2, they always go at the top above ABCs, because look at the number for 0, 1, 2. It's 48 and 49. It's less than 65 and 97. So yeah, when we're using sort to sort things in alphabetical order, these numbers are used. So that's why the numbers come out first, because it's got a lesser value. So everything is a number. Now let's look at some examples of some field sets. Of course, you got some rules that we're working with, and the sizes for different types of numbers that you're going to be representing. But let's take for instance one of these example data tables that your book provides, and we go into design view, and that's where we can decide on the design of the fields, the data types within a particular table. And so we have a volunteer ID, which is a primary key. You see the little key there? There's a little key there. That's done as a short text. Often this is usually done as a number, but look at all the different data types. A large number is just a big number, or a number that can get larger than a number. That means that more bytes are set aside to store that number. And, that's dependent on whatever technology you're using for data types. A date time, they even have a calendar data type. There's also in a lot of different databases, a file data type, so that you can store binary numbers in the database as a field. So that way, that when you create a database, you can upload files for like attachments on the web or something like that, because all that web, the cloud itself, is all driven by databases. Well, not driven. It's driven by applications that use databases to store that data. The files you upload, the posts that you set, that all goes to a database, because that's the standard way of doing things. It's the best way of storing data. It makes it easier and less work on somebody or on anybody within some kind of infrastructure to use a database to store data. If you try to do it by creating your own database, well, first the first question is why? Well, only if you're in a science class, a computer science class, will we talk about random access files and how they work. But why build your own database? Really, they're out there. The problem's already solved, and since we're so far along in technology, most of them you can use for free. So this is the design view. And this is the data view where you can actually start entering data, modify the database, go back to the design view, set your values and whatnot as needed. And there's another part of this design view that you can use, which is down here, where you can set specific properties and rule sets. You can set validation rules for a particular field type. So this is more, this part right here is more, the access front end type stuff, where this would be, it's less database theory back end type information. It's more about the, setting up the field type and the rules for that field type, where, if you had a website connected to the database, you would validate, instead of have access, do the validation with a rule. You would write the code to actually validate that data that's going in. So you can modify the field size, how large the first name is, how large the last name is. This is like in characters. And again, some of this stuff is all access specific. Okay, back to our PowerPoints. We talked about, data and what it is, and when we're working with table design, we want to make sure that we have some kind of structure and also some kind of data integrity. And so that's why data in a table should be given a primary key that is unique, so that you can manage the possible duplication of data, because I guarantee it's going to happen. The data could look like they're the same and not be the same. So first name, last names in a database. If you just went by first names, last names, there's quite a few John Smiths out there. How would you differentiate between John Smith? Well, we'd go to the address. Well, then, it starts getting to be a nightmare after that. So why control database integrity with repetition in that manner, when we can just say, hey, every piece of data in this table has a unique value associated to it? And then what that allows us to be able to do is use that unique value to relate to data in other tables that are the same. So we want tables to also kind of have a theme of the kind of data that's in there. So let's say add customer data, and then procedure data. All procedures have some customers. But every procedure that a customer has, other customers have the ability to have. So I mean, there's so much that can go into relating tables or relating data within some kind of discipline, like hospitals, anything where data is used, that a primary key is absolutely necessary. And that's part of a data table. Primary key, rows and columns. We can design data tables. This is for each column in this table. We can add columns to this. We can go down here and say something, whatever, and say short text, go back to here, save it, and we now have that in our table. The main thing here is we need a primary key, some unique value. They can be auto-generated with a numerical value, or you can have some kind of routine that generates unique IDs based on some important value within the organization. It could be taking the customer's first name, last name, and address, and grabbing different characters here or there, or doing something with the email, or it could be just your own personal algorithm within an organization to create an ID for a new customer that, you know, is dictated for one reason or the other. And that takes us back to some more PowerPoint. We're not gonna, let's see, where are we gonna get here? Okay. So of course, you know, I showed you a little bit in the design view in a new field. This is, you know, the picture that comes up in the design view. I think we're good with this one too. We just showed you how to add a record. Let's go ahead and review that again. So we go to design view, we go down to here, and we add a record to this guy. We select its data type. This is the column header. We say that that's a number. We save it, Control S. We'll go back to their view, and you see right here we have a number, a field that can take numbers. We can put a validation rule in there to check to see if somebody enters in that, you know, characters, JJJ, instead of a number. And where would we do that? We would do that. Come on, you silly goose. Oh, it caught it. Cool. It caught it. Access caught it on her, you know. We could, well, let me switch gears. We could decide that that number has to be between 100 and 300. And if we wanted to decide that that number has to be between 100 and 300, we'd go to that column. You know, every time we click on a column, its properties come up. We would go to that column and we would put in a validation rule. And you guys, this is very access specific, guys. This is only when you're learning this, working with it, the database in this manner. This is access only. So you can, the validation rule, you're going to be getting, you will be getting to eventually from your tutorials. Okay, what else do we got? This kind of overarching. Oh, new table. Okay, we can go over here. Let me think. We can say, we would create, go to the create tab and say table. And actually, let's put in some data, because I'm going to relate these tables with a foreign key. So what do we got in the other? We got volunteers. What kind of data would we have that's secondary to volunteers? Oh, we can say jobs. So this would be called jobs. We could rename this jobs, table 1 jobs. And we can go to design view, call it jobs. And now we can say, hey, we're going to have a primary key, and it's going to be an auto number. Then we're going to say, okay, well, what job? Okay, well then we're just going to have short text for the job. So every job is going to have an auto numbered ID. And then let's say, oh, time for the job. This is going to be a number, does not need to be a large number. And that's enough. And then we're going to save it. So now we've got 2 tables. Jobs and volunteers. Now, eventually, we're gonna relate these. Okay, so let's go back to our PowerPoint here, and we've got most of some of the overarching copy and paste the data from an open file. Okay, so yeah, this is importing stuff. This is all, there's all kinds of different types of data you can import. Text files with comma separated values. You can determine a different delimiter like spaces, like data that comes in a text file that's separated with spaces, white space. So this is the import tool that you would use, and you're going to have some instructions from your tutorial to do that, your tutorial and your case project. Okay, so you're going to be working with importing and existing a table or table structure. Let's see, you're gonna add fields and delete fields, rename fields. That's some of the stuff that you're going to get into. Now, you're going to work also in design view for your tables that you're going to import. Okay. This is where I want to get to. So after all that stuff that you do, like learning how to import and whatnot, now we get to, okay, well, we have some tables of data that represent, multiple tables represent a database, and so tables are contained in that database itself. So when we're working with a database, first we say, hey, what database do we want? Then what table in the database do we want? And that's for any programming, programmatically interacting with the database through a web interface. That's pretty much the way things are organized. And so your ACCDB file, that's your database. And inside your database, you have tables. And we just created 2 tables. We got 2 tables in there ready to be related. Now, why do we want to relate data? Well, let me do some scribbling, and let's talk about that. Hopefully, my scribbles don't get too messy. We'll see. How do I? Oh my gosh! It won't even. It's being a stinker. Here we go. All right, fine. Be that way. Let's just do that. Okay. So I was trying to clear it, but we got. Oh, that does not work one bit. All right, I finally got a nice fresh table. Let's get on this, or whiteboard. Excuse me, not table. Let's maximize this. All right. So why do we want to relate data? Okay, well, let's say that we have 2 bits of data. And 2 tables. And there's data in one table, data in another table. Okay, what if we want a customers from the customer table, jobs that were assigned to that customer in the jobs table? What if we wanted all customers that did not have jobs? What if we wanted all customers that had jobs? And when I say jobs, I'm talking like repair jobs or some kind of service that we did. It might be better to rephrase that service. Customers and a service table that describes the service, what went on, what happened, how many hours, or all kinds of stuff. But so there's 2 bits of data that we really want to know is what customers didn't have jobs or services, what customers did have services. So we call those different types of joins when we're when we're relating tables of data, because if I was a business owner, I would want to know what customers didn't have a service that, or didn't have any services in the last year. Maybe I would want to send them a reminder. Oh, hey, we haven't serviced your HVAC unit for a year. Please give us a call. We would love to be of help to you again. So there's so many uses for this way, for business, maximizing profit, for this type of way of working with information. All right, my scribbles aside, we're going back to PowerPoint. That's kind of, hey, how do we define those relationships? And we're going to get into that. But let's talk about the different types of relationships. Because what you can have is you can have one piece of data that has many all right, so with this one to many, there's another conversation which talks about many to one. So one to many relationships is where one piece of data can relate to many other pieces of data in another table, in another some other type of data that's being stored. So that means, hey, let's think about customers and accounts. Customers and accounts. Let's go back to our scribbles. Yes, we are there. So we got customers. I'm just going to call this C. And accounts, A. Okay, so at a bank, can one customer have many accounts? Yeah. So a customer to account is a one-to-many relationship. I know I have multiple accounts with my bank. Now on the flip side of that, with the same logic, some of you may have a bank account that you share with a spouse or a significant other. Accounts can have many customers. So that's a one-to-many relationship. So every account can have multiple customers. And that kind of interrelationship is actually kind of difficult to implement in computer science with that type of data structure. And that's kind of a little background on the one-to-many. Now, referential integrity, what that is, hey, what rules do we need to maintain to keep these two data tables that relate, to keep its data so that when they relate, there's integrity in that relational data. So what are those rules that, and we can set this referential integrity in Access. But what rules are applied? And so some of those rules would be when you have a related table and you update a record and you have a matching record in another table that has to match. So let's say that you have customer data and address data in two separate tables. Whenever you have a new customer, you're going to want to add an address to the address table from the customer table. And that's why, because you don't want customers without addresses. That sort of behavior would cause a problem And we call that kind of like an orphan record. When you do have a hard relationship between two different tables, so that when you update one table, the other table has to also be updated. That's one of the rules. And, other rules have to deal with changing primary and foreign keys between the two relating datas or tables. Now, here's a little bit on that. Here's the way that you could store this, and Access has its own way of doing this, but this is kind of a cheap and dirty way to relate the tables. I can go to the jobs table and I can look at the foreign key auto number. And what I can do is I can go over to the volunteers table and I can decide that this guy right here is going to represent the foreign key ID. And you would put the ID of the job in here because it relates. But that causes problems because that's kind of like this would be a number. And so what we could do is we can kind of relate those two tables by just having another value, kind of give you a very simplistic example of how relationships work. If we look over here at the jobs table, let's get out of the design view. Yes, I want to save it. We'll go to jobs. Come on. Let's say that I have job number 1 is trash, whatever, trash, and maybe 2 hours. Then I have job, this is auto numbered so I don't have to deal with that. Then I have sprinklers, and that was 3 hours. Stuff like that. Now I'm going to control S and save that. And then what we could do is we can go to volunteers and we could solve a job to that volunteer. Let's say that Catherine took out the trash. We would put the number 1 there. Alan also took out the trash. We would put the number 1 there. But here's the problem with doing it in this simplistic way, because this is a very simplistic way that we would relate the tables. How could we have multiple jobs attached to Alan? Because right now we only have the ability to store one ID. What if we had a table that would assign the volunteer ID? So now here we would add a foreign key. And this would be a number. So we would go to jobs, we'd go to the jobs design view, and we would add another ID, which is customer ID, which is going to be a number, so that every time that you added a job, every time you added a job, that job was given the volunteer ID of the volunteer that actually did that. And then you wouldn't need to do this sort of thing, because now you could, no matter what, you could list all the jobs that customer did by storing their ID in customer ID right here. So that this was number, volunteer ID 3452. So 3452 did that job, and then 3452 also did this job. And therefore you can actually have multiple jobs performed by one volunteer. And you would go in and you would look at one table, get the volunteer, get the primary key. Then you go over to the other table and you say, okay, Mr. Jobs table, give me all the jobs that customer ID 3452 did. And it'll give you all that data that matches with that customer ID. That is true one-to-many. And if you needed many-to-many, let's say that you needed a job to have many customers, you would then add a job ID, many jobs to have many volunteers. You could do that by adding a foreign key that represents, this foreign key would represent, oh, actually, no, you could do that. You could do many to many in this manner, because you would have the customer ID that would have many jobs associated to it. So, yeah. All right. That's kind of overview of data, and kind of how it interrelates. Now, I believe that takes us to the end of our discussion. Let's do this. Let's play around. This is going to be just kind of after hours playing. And what we want to do is we want to take and relate these two tables. Now, to do that, what I would do is I would go into design view and go to relationships. And let's see, what would I do? I would add tables to the relationships. What tables do I want? I want jobs. And I'm going to hit shift here to select multiples. And I'm going to add selected tables. Okay, and we see here that each table has a primary key. But what we want to do is we want to have the ability to go to a specific job based on a foreign key, pair. So what I would do is, okay, so each table has their own primary key, but we want to relate the volunteers table so that we have this kind of relationship, the foreign key of what is the job or the customer ID of that. Oh, why are you being a stinker? Okay, there we go. Control S. I guess we gotta do something to delete that. I'm not gonna mess with it. We want to have some way to relate with essentially volunteers with jobs. And the way we do that is by adding a foreign key. In this case, customer ID is our foreign key for volunteers or for jobs, so that we know that when we pull a job, we can have that customer ID be assigned that job. So then we go into relationships. All right, let me see. What we're going to do is we're going to relate the customer ID to the volunteer ID. This is the foreign key of the jobs table. And what I'm going to do is I'm just going to click here and hold my mouse and go over to here. And then I specify what is the primary key of one table and the foreign key, the value used to relate to the other key. And then I want to enforce the integrity rules for it. And then I hit create. It looks like, yeah, I think I need to save some stuff here. Let's see here. I got to get out of design mode, I think. Okay, I'm out of design mode, and I'm going to go to table, relationships. Now what I'm going to do is I'm going to take the foreign key and drag it over here. Volunteer ID will have many, let's see, a volunteer can have multiple customers. Oh no, multiple jobs. So I actually want this to be probably ID. No, this will be a one-to-many relationship. I'm going to hit create. Well, it kept on yelling at me until I closed all the windows. Now I'm going to go over here to database tools, relationships. Then I'm going to try to do the connection now. Okay, good. Force. Yeah. Okay, yeah, so I made a little bit of a boo-boo when relating to, because essentially customer ID is the ID field from the other table. And I set it as a number instead of what it is in the other table, which is short text. So they have to be the same because they are the same. A foreign key is just a primary key from another table. So I'm going to go to design view again here, and let's see here. This one has to be short text. Okay. Hopefully now we're going to make sure everything's closed. So go over here to the X, close out everything. Looks like everything's closed except for the relationships. Let's just do everything. Let's do everything. Close it all out. Now I'm going to go up here. Let's double check that jobs is set correctly with a short text. Good. Go to create. Where are you? No, database tools, yeah. And now I'm going to draw it over. Enforce. Create. So then we get into, well, why are we having this error? And that's because I did this all on the fly. And when you're enforcing referential integrity, you're saying that all volunteers will have a job somewhere, so that you don't have orphan records. So unfortunately, I don't think I can enforce. But that's fine. We're not setting it up so that every volunteer has to have a job. But you will be working with tables that directly follow the rules for referential integrity. So you'll be clicking that little referential integrity bit. So it was yelling at me because I didn't have every possible volunteer ID that had a job. Yeah. But these tables don't need that kind of referential because it's a one-to-many One volunteer can have many jobs. Okay. Alrighty, guys, that's enough for here. You'll be getting more from your book, of course, and some more in-depth examples. You'll be doing in-depth examples than my kind of flyby overview that we talked about today. So, yeah, thanks. Bye.